Hi, Manuvir. Thank you so much for joining. Welcome to the show.
Hi, it's a pleasure to be on with you. Thanks for having me. I'm looking forward to the session. And do you want me to just share my presentation now?
Maybe you can first do a short introduction about yourself.
Yeah, my name is Manuvir Das. I work at NVIDIA. I'm responsible for enterprise computing at NVIDIA. As you know, we're huge believers in AI. We've done a lot of work in AI, and we now see this phase of the journey where enterprise companies are really beginning to adopt AI quite heavily. And we need the developers in the community to really help enterprise companies make their companies better through the use of AI. So I think it's a fantastic moment to be having this conversation.
Yes, totally agree with that. So you're going to talk about the developer essentials for the new era of AI. Are you ready for it?
Yeah, I'm absolutely ready for it. So
Okay.
maybe I should share my presentation.
Yes, the floor is
Let me
yours.
take 1 second to get organized and
Yeah.
then
Where are you located, Manuvir?
I'm in Seattle, Washington.
Oh, okay, right.
In fact, I worked at Microsoft for many years, for 15 years. And I was part of the developer team, working on Visual Studio and things like that. So I've been born and raised as a developer myself, and I love the what developers do every day. The creativity, because
Yeah.
no one entity can have all the ideas. So you want to build a platform so that developers everywhere can just do great work with their ideas, but not have to repeat the same work that is common. So you build a platform with common tools, and then developers just build on top of that. I think that's a great philosophy.
Mhm.
So, okay, so I'm going to try to share this now. And do let me know if you're able to
Yeah, it's going through.
Yes.
see that. And I'm just going to put it into slideshow mode. Show it. It's not happening. So,
when I see the NVIDIA logo, I always think about gaming.
That's right. That's right. So you can see my title slide now, right?
See it.
Are you able to see my title slide?
Yes, we can see it.
Great. Okay. Yeah. So as you said, the title of the presentation is Developer Essentials, and what I really want to convey to the audience today is what we have been doing at NVIDIA to really help developers quickly contribute to this amazing area of AI. Okay. So I want to start with just for the one or two people in the audience who might not believe it yet, this is a massive opportunity for all of us. Just one study by McKinsey, for example, talks about $1 trillion of incremental business opportunity through AI. I think if you just look at the statistics of late, there's 96% of enterprise companies have some AI project at some pilot stage. So I would say, on the one hand, we're in this journey where companies are really beginning to understand that they ought to embrace AI, but many of them are very, very early in their journey, and they don't yet have the right applications and the right tools to get benefit for their use cases. So it's a fantastic time really to be a developer. The way we describe it sometimes from NVIDIA is this is like the smartphone moment for AI, where there's so many different use cases, and creative people can think about the different use cases and build AI solutions for them. And our role at NVIDIA is really to try to provide that smartphone, that is a platform that people can use. And of course, you heard from Eric and the great work that's happening at Microsoft. There's a number of companies. So this is clearly something that we are part of, that we participate in from NVIDIA, but as well, so many others do as well. And we just try to make our own contributions. And so what I wanted to share a little bit today was the ways in which we at NVIDIA are trying to make our contribution in conjunction with Microsoft and Google and Amazon and just so many providers out there. Okay. So just a few facts just to get everybody caught up on who we are and what we do for AI, because it's easy to think of NVIDIA as the gaming company or the graphics company. I think a long time ago, a decade ago, at least, we realized that the same acceleration technology that we have in our graphics card turns out to be the perfect acceleration technology for deep learning, which of course is a fundamental part of AI. And so that's when we embarked on this journey of accelerating AI. And what we saw were dramatic accelerations, right? 10x, 20x, 100x, a few 100x times acceleration, which really made those algorithms tractable for the first time. And so since then, just some stats for you. We have more than 1 billion GPUs out in the field. We have our SDK called CUDA, which is our lower level interface for programming against a GPU. I'm sure many of you in the audience are familiar. We've had, a lot of downloads, as you can see, thousands of applications developed. The thing that we're most proud of is we have 3.5 million developers registered who work with our stack in various different ways. And that's really the main thing, because that's how everybody in the community can benefit from the work we do. So I thought I'd put that slide up there just to give you an idea. I thought I would share 3 ways of thinking about our contribution. The first, of course, is that I accelerated the GPU. And as you know, we've taken the approach that we have an interface called CUDA. And as we move from one generation of GPU to the next, or from one kind of GPU to another one, even in the same generation, we have one API, which is called CUDA. And so what that does is it makes sure that as a developer, when you program against a part of our API for some functionality, then it's the same code that you can have regardless of which GPU you use. And then when we move from one generation of GPU to next, your code carries forward, right? So that's very important to NVIDIA's approach. And of course, I think it's very important for developers. So clearly we have accelerators that make AI go faster. And we, as you know, we participate in MLPerf and these things. And we are number 1 on that regard on all the benchmarks. We are a full stack company. I think there was a person who said a long time ago that people who really care about software do their own hardware. And at NVIDIA, we do the full stack. So we design the GPUs, we design the systems, how GPUs are connected together, how they're connected to the CPU, what the interconnects look like, how much memory you have on board with the GPU on the device. So we think about that whole architecture, and then we go up from there. So anytime we are working on a particular workload, for example, large language models, we do all the software algorithmics to do the training for large language models, but we're also very aware of what the bottlenecks in the hardware can be, and then we design the hardware accordingly. And as we evolve our GPUs, for example, we put in different kinds of operators into the GPU to enable more efficient processing of some of those algorithms. So we are very much a full stack company, and we optimize across the full stack. And then finally, we run a lot of software. NVIDIA today is much more a software company than a hardware company. We have thousands upon thousands of software engineers. We have more software engineers than hardware engineers by far. And we've developed a huge number of SDKs, and we make them all available. And many of them are, of course, available on GitHub. And so they're pretty easy to find over there. And we work with the community on these. I'll go through these SDKs a lot more. But so this is one slide to say, here's the 3 ways you can think of us and our contribution. At the base of it, we build these hardware accelerators that anybody can use to really dramatically speed up these workflows so that they become practical. The second part of this is we optimize across the full stack, and then we make all the software available to the community to use and to build upon. Okay. I think a good point to make here is that there's been, an interesting inflection going on that many of us are aware of, which is that more and more of the workloads are in the public clouds now. And that movement is just going to continue, right? And as some of the companies that you're familiar with have done an amazing job building this cloud infrastructure, right? And so there's good reasons why the world is moving to the clouds. Now, the reason I bring this up is because NVIDIA is the accelerated computing company. That's what we do with our hardware and software. And there's two ways of thinking about why accelerated computing matters and why, as a developer, building an application or some kind of platform, why you should care about accelerated computing. The old reason was that when you accelerate your application, it runs faster, you get results faster, you can process a bigger workload and all of that, and that provides value to your ultimate user or customer, right? But now there's a second value of accelerated computing which becomes crucial, which is that it saves money. And the reason it saves money is if the same workload can be run on a fewer number of servers over a lesser period of time, then even if the cost per server is a little bit higher, the overall cost of running the workload is much, much lower. Now, when you're sitting there running your workload on premises or running your application on premises, you've already got the infrastructure, the non-accelerated infrastructure in your building. And so, yes, I can come to you and say, hey, here's this other infrastructure with acceleration in it. And if you run over there, you'll save money. But at the end of the day, you have to procure the new equipment. On the other hand, think about what happens in the cloud. When you run something in the cloud, you're renting instances. You're renting them by the hour, by the minute. So as a developer, if you have built an application or a workflow in the cloud and you choose to integrate with acceleration to make your workflow go faster, you're going to immediately save your customer money because they're going to have to rent fewer instances for less amount of time. And again, even if the rental cost per instance is higher, the overall cost is going to be much, much lower. So I think that's an important thing to keep in mind and consider. Okay, so this body of software that we've been working on for years now at NVIDIA, we think of it as two levels. Okay, one is we have a plethora of SDKs that are like building blocks and tools that a developer can use to do their own work. For example, we have GPU accelerated TensorFlow and PyTorch, and you can use that if you're doing some deep learning for part of your workflow. And I'll talk about more examples. And we've had that for a few years, and they've been quite widely used. But in the last couple of years, we've really put a focus on what we call workflows that are higher level pieces of software. As you all know, any AI use case involves multiple steps. It's not just one piece of code, right? You have to process the data, you have to do some training, then you do some tuning, you do inference. There's many steps involved. And so we've built a whole set of libraries, if you will, now that are for these end-to-end workflows. And I'll be sharing that list with you and talking about that a little bit more. So I think there's two ways to engage with the software of NVIDIA. One is at the level of picking up the lower level tools and doing your own end-to-end workflows on top of that. And then the other is just to adopt one of our workflows and build upon that. Use that as a starting point, a reference design, if you will, and then either extend it or modify it or integrate it into what you've got. So two ways to develop. Okay. Again, we know that AI is essentially a four-step process where you find your data, you prepare your data. That can be quite a time-consuming process. And then you do your training, whether it's deep learning or simpler forms of machine learning. And then you do some level of tuning, optimization, and then finally you deploy for inference. So at that lower layer of tools, we've got a number of tools that make this feasible. We built something called NVIDIA Rapids. It's open source at rapids.io. And it's basically the data science constructs you're familiar with, like pandas, that we have built versions of these that are accelerated on GPUs, and they are dramatically faster. On benchmarks, you'll see 20 times the performance, 25 times the performance. if you target these your data processing to GPUs. We're all developers here. It's not a free process. We match the APIs, but it's not a flip a switch and it just works. There's some amount of retargeting that one has to do. But if you do that retargeting, as I said, you get orders of magnitude benefit. The other approach we've taken along the way is we've also taken Spark, which is very commonly used for data processing, and we've used the same Rapids libraries to accelerate Spark. Now that one we've done completely transparently. You literally flip a switch, you don't change anything else, and some of your operators run on GPUs instead of CPUs. You get lesser performance benefit. Instead of order of magnitude performance benefit, you'll get several times performance benefit. And again, it just saves money because on a TCO level for the user, but it's completely transparent, right? So two ways to go to improve your data processing. Either you adopt Rapids and do the retargeting from Pandas, etc., to Rapids. There's a little bit of retargeting you have to do, and you can get dramatic acceleration. Or you just use your Spark pipeline and you just flip a switch and and you get instant benefit with no code changes at all, right? So that's Rapids. And then for the training, we've got PyTorch and TensorFlow targeted to GPUs, and we constantly optimize that. We've got something called Tau. Tau is basically for your retraining loop. You've trained a model already. You've got a pre-trained model. Now you want to add some data that you have or a different context, and you want to retrain. So Tau is a toolkit that enables that loop, if you will. For a long time, there was a belief that you do your training on GPUs and you do your inference on CPUs. And what we realized a few years ago that actually the GPU accelerator is an awesome place to do inference. So we built a runtime called TensorRT. And then on top of that, we built a library called Triton, which is basically an inference server for model serving. And it's very, very performant relative to CPUs. It's, there's a lot of advantage, both again in TCO in terms of how much hardware you need to use. And also, especially when you're in real-time use cases, then you get much faster result. So you can do interactive kind of things. So that's NVIDIA Triton. So that's a glimpse of what we have in the lower layer, if you will. And then the other way to go is at the upper level, as I said, where we have more complete sort of workloads for particular use cases. So I'm showing this to you here, and I've broken it down by areas. So the way to understand this is basically each of these frameworks that we've built is for a particular domain that I've put in parentheses under the name of the framework. And then at the top of the slide, I've given examples of use cases that one can use. So for any of these frameworks in its domain, it enables a plethora of use cases. And then as a developer, what I can do is I can take one of these frameworks and I can add whatever else I need to add to complete the use case. So as you all know, a very, very common application of AI is video analytics, out on the edge, in factories, etc. We have a framework called Metropolis that provides all the common functionality for video analytics. And then you can use it for a variety of use cases, and I've given you one example there with traffic, right? We have a framework for conversational AI. It's called Nemo, and that's where we do a lot of work on large language models. And so you can imagine use cases like chatbots or for employees at a company, accessing a knowledge base and such. We've got a very interesting framework called Morpheus for cybersecurity. Every company cares about cybersecurity now, and for developers, I would say, there are obviously large companies focused on cybersecurity that build big products that cover a range of things. But interestingly now, as a developer, you can quickly build particular solutions for particular aspects of cybersecurity that companies find valuable. And I'll give you one example from NVIDIA. NVIDIA NVIDIA's corporate network was actually compromised in February of this year. We were attacked. And what we realized was that we have so many employees logging in and using different systems, and one of our employees had been impersonated, and then that way they got access to our network and extracted some amount of information before we found that and we blocked that. So we built an AI framework called Morpheus. And we did this use case called digital fingerprinting, where basically we gather all the logs from Azure Active Directory, from Duo standard systems that we use in our company. And we feed this to our AI engine in Morpheus. And basically what it's doing is it's creating an individual model of every employee in the company in terms of what their regular pattern of behavior is. Do they go to the travel website? Do they go to the expense reporting website? What do they do in a normal day of their life? You build a sort of a model of each employee. And then against that model, the system observes the actual interactions of the employee. And so as you can imagine, it can flag when it sees abnormal behavior, right? It's like anomaly detection with AI. And we use this system every day at NVIDIA, right? And it's one of these point use cases. So any of you can pick up this framework we've built for cybersecurity called Morpheus and go develop use cases like that, whether it's digital fingerprinting or anything else you want to do. Riva is a framework for speech AI, for ASR, which is audio to text, for text to speech TTS, and it can be used in chatbots and lots of different contexts. Trading floor transcription, for example, for banks and financial companies that have saved all the audio recordings of the interactions, and then if you convert it to text, obviously that makes it easier to process. So that's called Riva for speech AI. Merlin is our recommender system framework. As you know, recommender systems are what drive the internet today. It's all about personalization and showing people what to watch next, what to read next. And so that's a framework for that. Modulus is we model actual physics and do very accurate simulation of physics. And then finally, Co-opt it's basically solving the traveling salesman problem, but on GPUs, so much more powerful with certain heuristics so that these problems become tractable. Okay, so this is a quick rundown of our workflows. So the final point I wanted to make was that we love the choice that customers and developers have in front of them today, which is there are public clouds. Obviously, we've got Azure as a good example. You just heard from Eric, but we've got all the public clouds, and then you've got other providers in different regions that also provide shared infrastructure. You've got people running on premises. You've got co-location areas like Equinix, etc. So customers can really vote with their feet as to where they want to run a particular workflow. And what we have chosen to do at NVIDIA is we're an open platform company. We're agnostic. We build everything so that it can run everywhere, right? We love containers. We put everything into containers so that you can do Helm charts and run things on Kubernetes. We avoid taking dependencies on particular things that are only found in one environment versus the other, and that allows us to be quite portable, right? So those frameworks and things I was showing you earlier, they run anywhere. So the easy way to interact with us is to join our developer program. It's developer@nvidia.com. As I said, our stuff is available everywhere. If you go to NGC, this is the repository where we make everything available. It's all free. It's all containerized. A lot of our code is also on GitHub. So you can either just go to GitHub and pick up our code and do the usual thing of playing with it, or you can go pick up the same stuff, but it's packaged into containers, so it's very easy to deploy. And then the thing that I'm really excited for all of you that we focused on a lot in the last year is we've built this experience called Launchpad that any of you can sign up for, where we've spun up infrastructure, a lot of infrastructure, and these workflows and things that I showed you, they're all available there. So if you sign up, you can try out these different workflows and you can do your own development and make very rapid progress. And the experts that we have at NVIDIA, the data scientists, the engineers who develop these workflows, etc., they can work with you very closely to help you as you develop your application. So I think that's a great starting place, which is just NVIDIA.com Launchpad. So 3 things to remember: developer.nvidia.com, which is the way to connect it with us and find everything we've got. NGC is our repository where you can easily pick up all these things in containers. And then Launchpad is this sort of free experience where you can try everything out. So really super excited to have been able to share this with you all. It's a very exciting time for AI, and looking forward to working with all of you going forward.
Manuvir, thank you very much, and very good to see that NVIDIA is really putting a lot of effort in AI. I was a bit surprised to see that all those models are already pre-built by NVIDIA.
That's right. That's right. And I had the schematic I realized that talked about the SDKs and the frameworks, but in the process of building these frameworks, of course, we've done a lot of training ourselves on the infrastructure we have. So we have a lot of pre-trained models that are also available at NGC. So for a developer, you can pick up the code that we've built and build your own solutions on top of that, but you can also pick up the pre-trained models that we've created, and you can start from there. So you don't have to start all your training from the beginning.
Yeah, I'm definitely going to sign up for your developer program after this evening.
That's
I think
lovely
we need to
hear.
advertise it a little bit more, because I also had never heard about it. So I think it's something that the community needs to more
That's
about.
great feedback. So firstly, I really appreciate the opportunity then, because at least I was able to share that with your audience. But yeah, your point is well taken. We're really going to focus much more on sharing this with everyone. Yeah.
Because at the end it makes sense. You make the hardware, and to have the hardware, you also need to have something that's how do I need to say it, who can interact with the hardware to try it out, and to build extra services as well for your own organization. And you build out some research.
Yeah.
And if you can share that research, that's awesome.
Yeah.
Yeah, because the experience we had was that as we got into AI, we got into all these new use cases that nobody had really done before, right? And as we worked with companies, we realized that somebody has to build that software for that use case. And we ended up being the people who built that software. And that's how our company really evolved and became a software company, So,
Yeah.
And we're super excited to share all that body of software, with the community. Yeah.
Really great. Thank you so much.
It's my pleasure.
For joining us and for your session. And have a great day.